Hello, this is Mr. Win, and this video is over oblique triangle applications or word problems. This will require using a calculator. Make sure it's in degrees mode and not radians. And these are kind of tough, so make sure you join the live sessions. Basically, trig applications of word problems aren't really different than what you've done before. You're going to be asked to find one of two things, or maybe both. The first thing is the distance from the starting position. The second thing is the angle or bearing from the starting position. The two twists you need to keep in mind are one, angles and bearings. Remember, start from the very top and go clockwise. Remember, true north. So 0 degrees on top and 90 degrees on the right side instead of the normal unit circle. Then second, oblique triangles require using the law of sines and cosines. Usually it's going to be both. All right, make sure you draw your pictures very, very carefully. So we'll start easy. Starting from home, Zosa jogged 3 miles due north. Due north means straight up. So starting from, I'll say origin, I go straight up 3 miles. Then she turns and jogs 4 miles due west. Due west is directly to the left. All right, so that's this right here. That is 4 miles. All right, how far from home is she? So she ended right here. She started right here. They're trying to figure out what is this distance, x. All right, also you gotta know if you have a vertical and horizontal line, they are perpendicular. So this is 90 degrees. We could do SOHCAHTOA in Pythagorean theorem, but we're not. We're gonna use the general formula. But again, how far is she, and then what's her bearing? So first find out how far is she. So can I do the law of sines here? Answer is no, because I don't have an angle with the side across from it. So I'm going to do a law of cosines. I'm going to use the x side on its own, so it'll be x squared equals the other two sides squared added together. The order does not matter. Minus 2 times those two sides being multiplied times cosine of the angle, which is 90. All right, we solve this. 4 squared is 16. 3 squared is 9. And this 2 times 4 times 10 is cosine 90. Cosine 90 is 0. That's going to be minus 0. Combine that. X squared equals 25. Square root both sides. We get x equals 5. We found this is 5 miles, which would have got the same thing from Pythagorean theorem. Pythagorean theorem is actually just a special case of the law of cosines. All right, now we need to find the angle, the bearing. We have to find, I'll call it this angle y. Can I do law of sines now? The answer is yes. If I do law of sines, I can say sine of 90 goes with 5 equals sine of y goes with 4. Well, sine of 90 is just 1. That's on the unit circle, but usually you won't have that number. So I'll just replace it. Solve by getting rid of fractions. I multiply both sides by 4. So that's really 4 over 5 equals sine of y. To get sine by itself, you need to arc sine or inverse sine both sides. So I'm going to do inverse sine, arc sine. If I type that in the calculator, I will get 53.1 degrees. We'll round to the nearest tenth. All right, so we just found this angle, 53.1 degrees. All right, now when we talk about bearing, there's two notations. Let's do the true bearing first. True bearing starts from the top and goes around. Here's the true bearing. We're going to go from here, go all the way around to find this angle. So we want 90, 180, 270, then a little bit more to find this number. To find this number right here, we have to do complementary angles. This makes 90 degrees. So I'll do 90 minus 53.1. I get 36.9. This is a 36.9 degree angle. All right, now I can add them up. So I can say, what is that? 270 plus 36.9. That gives me a 306.9 degree true north bearing. All right, so we have the distance, 5 miles. So add units to that. And we have the bearing true north. If you want the other notation, that's like the north and then either direction or south either direction. We could say we went north. We turned 53.1 degrees west. All right, so those two bearings are the same. Without any words, that means true bearing, 306.9 degrees. But if I tell you north, that means you went up, and then you turned to the west. You went leftwards west. That's why this is 53.1. All right, let's try the next problem. Muna took a flight for vacation. The airplane took off from the airport at a bearing of 20 degrees true north. So let me move that. Here's this. All right, true north. And this is 115. I'll just put it up here. All right, true north means this angle right here. That's 20 degrees. If you want this angle right here, that's 70. All right, you're going to need both. All right, then the plane realized going the wrong direction, change course to bearing 140 degrees true north. So the reason why we like true north is it doesn't matter which direction the plane is facing, true north starts from the very top. So from this point of view, they're going to go 140 degrees true north. So we're starting at the top. Here's 90, and then we're going to do 50 more. So something about right there. That would be 140 degrees true north. So it should be this line. See how close I am? Kind of close. All right, so we now have this, but we need to figure out how much each angle is. If this top part is 90, this is 50, and that's 50, and this is 40. All right, from there, move the 600 right over here, and then we can try to answer the question. How far we're landed here, or we're there. How far from the beginning? We're trying to find this side. All right, can we do law of sines? No. Law of cosines? Yes, but we need some more information. So the reason it's called the triangle method, why there's two methods to solve, triangle method and parallelogram method, they're the same thing really, just how you want to find this important angle. So this is called the triangle method because I'm trying to find this angle right here. It's very important. I know the right half is 40, but I don't know the left half is. It's not even half. It's right side's 40 degrees, the half we'll figure out. So it's called the triangle method because we keep the triangles there. We don't draw anything else. We notice if you know parallel lines and transverse, if I extend this right here, that line's parallel to this, and we have a transverse to this red line right here. Alternate interior angles are equal. So if I erase those things, we know that that's 20 degrees. This inside piece is also 20 degrees. And if that's 70, then this outside piece is 70 degrees if you draw the right angle there. But anyways, now we have the two angles together. We can add them up to say this is a 60-degree angle. That's going to help us. So now I can do the law of cosines. So x squared equals the two other sides squared added together in any order you want, minus 2 times the sides multiplied together, times the cosine of the angle across from our lonely side, cosine of 60. That's because it's a unit circle number. We could actually solve this without a calculator, but it's a big number, so I won't. I'll just use calculator. Square root both sides. You get x equals 551.6. Not degrees, miles. All right, so we found how far we are from our starting location. This is 551.6 miles. All right, so one question answered. Next question says, what is the true bearing? All right, so we have a couple ways we can do this. Let me say this. Notice our triangle. If I kind of isolated it, looks like this. We know this top angle is 60 degrees. This bottom side was x, or I guess 551.6. And this was 600 miles. And this was 115 miles. All right, we can now do law of sines to find this angle right here. But this angle only is this angle right here. All right, and that's not going to tell us too much. We do need it. So let's find it first. So I do law of sines. What is that? Sine, we'll call this angle y. Sine of 60 goes with 551.6. And sine of y goes with 600. Multiply both sides by 600. That's sine of y. We're going to arc sine both sides. Inverse sine. Type that on the calculator, and we will get 70.4 degrees. All right, so we found that this thing is 70.4. If I want the true bearing, I have to add this top part as well. So I can do 20 plus 70.4 to get 90.4 degree true bearing. True north. If I want the other notation, I'd have to find this thing right here, going south, and how much are we turning? So we're south, we're turning some direction, degrees west. We gotta find what this little piece is. If we know the whole thing is 70.4, or you know the whole thing is a 90.4, you can subtract 90. Okay, this is 0.4 degrees. So that makes this, if you do 90 minus 0.4, that gives you 89.6 degrees. So we did south, 89.6 degrees west. That's the other bearing notation. All right, one more. JP took his boat on the water from port, started south So going towards south direction, but turning 30 degrees west. So he went down and turned left. So this right here is a 30-degree angle. And this makes a 57-degree angle because it's going to make 90. All right, and then this is called the parallelogram method. So you'll see what I make in a second. It says next he changed course to north, going north 24 degrees west for 3 miles. So instead of putting this right here and making a little coordinate plane and trying to the XY axis and trying to find the angle, I'm just going to put it back to the original, start everything from the origin. Here, going up and turning 24 degrees west, that means this is 24 degrees. If you subtract 180 or 90, you'll get a 66-degree angle. All right, I'm making a parallelogram because really that side was supposed to be right here. And then the other side completes the parallelogram like this because those sides are parallel. We want to make a parallelogram because we know a parallelogram makes 360 degrees and opposite angles are the same. So if I add these two numbers up right here, 66 plus 57, I get 123. If that left side is 120, this is also 123. If I do 123 plus 123 and subtract that from 360, I get 114. That divide by 2, I get 57. So I know this top angle is 57, this bottom angle is 57. So the parallelogram method helps you find this 57 number easier. Because if you remember the last problem, we had a little bit of trouble trying to get the 60-degree angle right here, right? Because we had to think of 20 and 40. If you do like this, you'll find that number easier because we will need this number in a second. All right, so the magic here comes from this. Once you have your parallelogram filled out, draw our real thing. So we're starting from the origin, we're actually landing over here. So I'm going to kind of isolate this triangle. And let me just say this. This was 10 miles. This was 3 miles. All right, so this triangle is what we have. We know this is 10. We know this is 3. We know this is 57. We do not know this angle right here. We know it's a piece of this 123 because 123 is the whole thing. See that? And then we don't know this angle right here either. Right? Because that's this little piece right here. We don't know the top piece. And we don't know the bottom piece, which we will need later on. Because that's what it looks like. All right, so we're going to do the law of cosines because we don't have a side and everything. This is x. So x squared equals 3 squared plus 10 squared minus 2 times 3 times 10 times cosine of 57. Here we have to use a calculator. I will square both sides though, so I can do it all in one step. I will get 8.7 miles. All right. So we found this number. Now we need to find this angle. I'm going to look for this angle next. We'll call that y. We'll do law of sines. So sine of 57 goes with 8.7 miles. That would be sine of y goes with 3. Multiply both sides by 3. 3 sine 57 over 8.7 equals sine of y. Arc sine both sides. All right, type in a calculator and I get 16.8 degrees. 16.8 degrees. All right, so we now know this piece is 16.8. Let's try to find the true bearing. We have to find from here, that's 90, 180, plus this piece 33, plus this piece was a 16. Because remember, this was a 33 angle out here. So I'm going to do the adding method. So 90 plus 9 is 180, plus 33, plus 16.8. Type that in the calculator. You should get 229.8 degrees. That is our true bearing. If you want the other notation, we only need going south. How much is this right here? That'd be 33 plus that 16.8. So that'd be south 49.8 degrees. Turning never eats something west. All right. So that's it for the video. Hope you're watching. Make sure you ask any questions. Also, last thing I mentioned, I did the adding method to find the true bearing, but there's a subtraction method as well. If I go back to this other one, so we got 306.9 degrees, and I did the 270 plus that 306.9. You could have done 360 minus that 53.1. Some people like subtracting more, and they'll still get the same answer, 306.9 degrees. All right, thanks for watching. Ask questions. See you soon. Bye.